The quantification of noise pollution due to vehicular traffic for the city of Allahabad will be helpful in designing various mitigation measures for noise sensitive areas of the city. The air pollution monitoring data has been used to develop various models.
The varying noise levels are in accordance with the varying traffic levels at identified locations in the city. By using the FHWA model, an equation for highway noise prediction for Indian conditions has been calibrated for Allahabad. Chandigarh, a newly planned city, has the rare distinction where every person who's capable of driving or riding a motorized vehicle has one. The city has the highest vehicle to population ratio in the country. The Punjab Engineering College carried out the studies and created the database here.
The urban environment of Chandigarh is suffering because of the heterogeneous nature of the traffic and its exponential growth. I compliment AICTE for focusing its attention on the urban transport environment interaction. I would also like to compliment IIT Roorkee for initiating this scheme and for having recognized the potential of PEC and making its partner.
The entire Chandigarh was divided into 4 zones: silence, commercial, heavy traffic and the residential zone. Now in each zones, 2 localities were identified and where the environmental pollution parameters such as noise and the air pollution were measured, and of course traffic as well as the speed data was also collected, and of course the effect of the greenery on the noise pollution was also determined. Now Chandigarh cannot be called to be as a pollution free area, so all the parameters are having a alarming increase and they have to be, you can say, kept in check.
Though there have been attempts to assess the ambient air quality of Chandigarh, this study is the first of its kind where a correlation between deteriorating environmental quality of the city and the urban transport was established. This study has not only estimated the air and noise pollution levels but also proposed predictive models for the same. These models would be of use in environmental management as well as traffic planning.
In residential zones, the traffic is at a peak between 9 to 10 am and 5 to 6 pm. At Sector 22 on working days, the traffic is near about 600 PCU per hour and 1100 PCU per hour between 9 to 10 am and 5 to 6 pm respectively. At Uttar Marg 2, the variation of traffic is mainly seen at peak hours. Models for traffic noise and air pollution prediction were developed for Chandigarh city. Lucknow, a historic city of Nawabs on the banks of the Gomati River, is the capital of the largest populated state of the country, Uttar Pradesh. Lucknow too suffers from traffic congestion, an offshoot of development. Studies in Lucknow were carried out by the Institute of Engineering and Technology, Lucknow.
It is a matter of great pleasure that the IIT Lucknow is a partner in this AICT NCP Urban Transport Environment Interaction. This project is of great significance in the light of growing environmental pollution in metropolitan cities due to the transport system principally. And capital of UP had a glorious past, and the growth of the activity has resulted in growth of vehicular population. This study has rightly included Lucknow as a case study focusing on a study of the interrelationship between environmental pollution and transport system. This project has been beneficial to initiate research activities in the area of transport related pollution in UP.
Civil Engineering Department of this institute is participating as a partner in the nationally coordinated project on urban transport and environment interaction. This is a very good project and is itself one of the best projects being carried out in India. With this project, the student of our department will also be benefited on account of the fact that the equipments, latest equipment which will be purchased for the project will naturally be utilized for the student cause also.
We have selected 10 locations for our study. On the basis of the locations, we have divided the total area into the 4 parts, and the air and noise pollution studies have been carried out at all these locations. It has been found that the air and noise pollution levels at all the selected locations are much higher than the prescribed limits. It is recommended that use of old technology cars and other vehicles is to be removed from the Lucknow city, and a proper enforcement technique is to be applied for regulation of the traffic.
Traffic noise levels in Lucknow exceed permissible levels at all locations and were significantly higher than the prescribed limits. The traffic volume is high at all locations, resulting in higher noise and air pollution. The plantation of trees and the diversion of traffic near the KGMC can reduce the noise pollution in the silence zone. The noise level is showing an alarming rise, and in fact, levels exceed prescribed standards in most areas. The loudness of traffic noises increase due to heavier traffic volumes, higher speed, and a greater number of heavy vehicles.
On our metropolitan streets, the congestion is of a very high order, followed by very high levels of noise and air pollution. In order to study this problem, the Indian Institute of Technology, in cooperation with four other institutions, undertook a major research study how the ill effect of noise and air pollution can be modeled, and remedial measures can be taken to contain these ill effects to a manageable level. The study has come out with very valuable and practical suggestions to improve the situation, and I am very sure that the findings of the study will be of practical value to all the major metropolitan cities and other towns and highways in our country.
The growth of the cities, if it is not as a planned manner, it results into absurd growth, and the urban area gives to a deteriorating transportation system. The use of public transport will help in reducing the pollution, provide good environment. Ideally, if we go for the modes which use minimum fuel per person, will provide minimum pollution.
Vehicular noise is a combination of the noises produced by the engine exhaust and the tires. Traffic noise levels increase due to defective mufflers and other faulty equipment on vehicles. Conditions such as a steep gradient causes the heavy laboring of motor vehicle engines that increases the traffic noise level. Excess noise levels are proven to be responsible for various problems in human beings. Noise levels must be controlled in order to reduce the societal impacts of it. A reduction in noise levels may be achieved by motor vehicle control, land use control, highway planning and design, buffer zones and noise barriers. Also, a new road can be located away from noise-sensitive areas. New roads can also be located in undeveloped areas. A new road can be constructed below the ground level. Also, a new road can be designed and constructed as level as possible. The elimination of a steep gradient helps to reduce the traffic noise, as multi-geared truck engines do not have to work as hard. The noise generated by the traffic under interrupted flow conditions is an aggregation of individual vehicle noise output. Vehicle operation conditions here are predominantly those of acceleration and braking rather than the constant speed situation of free flow.
This project has achieved its objective by generating the data, the needed data for modeling the air pollution as well as noise in reasonable manner. Air pollution is really a serious issue. Delhi is a specific case. About 6 years back, the condition of Delhi was in a serious situation. However, this was rescued by some bold initiatives like the Vehicle Technology Initiative, removing the very old vehicles from the road, particularly the commercial vehicles, and also changing the fuel of the public transport vehicles. So thus, the vehicle technology policy, the fuel policy, as well as the I&M policy with respect to the urban transport is a very serious matter, and these can make the situation much better if we can adhere to the good examples followed in other countries.
Air pollution due to transport is because of carbon monoxide, hydrocarbons, nitrogen dioxide, sulfur dioxide, lead, and suspended particulate matter. According to a report by the Central Pollution Control Board, out of the total pollution load, 65% of carbon monoxide, 22% of hydrocarbons, and 12% of oxides of nitrogen are caused by petrol and diesel vehicles. Two-wheelers and cars, which are mostly used for personal transport, are major contributors of vehicular pollution. According to a study conducted by RITES, the share of two-wheelers and cars towards pollution in metropolitan cities is 78% and 11% respectively. Petrol vehicles account for nearly 94% of the total carbon monoxide emissions into the atmosphere. The air pollution can be checked to an extent by adopting measures like the use of unleaded petrol, the use of catalytic converters, the use of diesel containing minimum levels of sulfur, the use of alternative types of fuel, the elimination of two-stroke vehicles, proper engine maintenance, growing trees along the highways, creating awareness amongst general public, strict enforcement of pollution norms, proper traffic management, and providing an efficient public transportation system. Emission norms also need to be tightened. It is time to bridge the gap between Euro norms and Indian norms. Euro 4 norms for petrol vehicles and diesel passenger cars and Euro 2 norms for heavy diesel vehicles may be the preferred target for the year 2005. These are the salient findings of this project. The studies team has come out with a number of recommendations to be implemented by various government and non-governmental agencies. Using the traffic noise model in this study, a noise dust barrier has been designed for the Britannia Chowk flyover in Delhi. This noise barrier has been embedded into the crash barrier. Plastic sheets are being used as noise barrier material. The Delhi PWD is implementing this project.
As far as the noise barrier design and at the same time control of pollution in the urban localities was concerned, finding was so much useful that we were very much tempted to use in one of the highway projects of the which was taken in the Delhi for Britannia Chowk flyover recently, and the finding of this research was very gainfully utilized in the design of our noise barriers.
Center of Transport Engineering Department of Civil Engineering IIT Roorkee has been our partner in this venture, and with their advice, noise and dust barriers are being provided for Britannia Chowk flyover in Delhi. This noise barrier shall reduce noise level in the adjoining residential area below the noise level prescribed by Central Pollution Control Board. The government of Delhi has taken a decision that noise barriers dust barriers will be provided on all flyovers in Delhi, particularly in residential area, after knowing the feedback and utility of noise barriers being provided at Britannia Chowk flyover and in the first phase.
With the present nationally coordinated project of R&D study sponsored by All India Council for Technical Education, it will be possible to revise the IRC code incorporating different models of noise and air pollution, methodology for design of noise barrier, etc. I am confident that the findings of this project, a code may be developed for professionals to work out solutions for managing transport-related pollution in metropolitan cities effectively and to improve the quality of life.
As part of this study, a panel discussion was also organized at Roorkee, where representatives from different organizations concerned with the study of the subject participated. The funding of this study has been appreciated by all the participants. All the 5 institutions have enriched by the scheme. Several MTech dissertations, 4 PhDs are in progress, and 27 research papers have come out of this project.
A large number of research papers, MTech theses and PhD theses have come out from this nationally coordinated project.
It was in 1995-96 as the chairman of the All India Council for Technical Education, we conceived an effort to be launched in the Indian higher education system by establishing nationally coordinated projects. The first one that we thought about was in the urban transport and environment interaction. Conceptually, it was networking of eminent educational institutions and their dedicated human resource, Indian Institute of Technology, Roorkee, as a team leader, grouped together 4 other institutions in the country and launched this project in a very massive and dedicated manner. I am very happy that the IIT Roorkee is in a lead role, and it is felt that we need to have a second phase of the development to be more precisely conclusive, to create models which are geographically transferable in the country.
The team is hopeful that these studies will facilitate the policymakers and the stakeholders to curb and control the menace of air and noise pollution generated by the metropolitan transportation system.